Okay, so today we're going to cover 2.6 and 2.7. Your book splits them up as two sections, but when I teach this normally, use only one section to teach this. So I'm just going to kind of combine 2.6 and 2.7. So solving absolute value equations. That's what we're going to cover in this section. And the next section will be solving absolute value inequalities. So the first thing is solving an absolute value or solving equations of the form absolute value of x is equal to a. If a is a positive number, then x equals a is equivalent to x equals a or x equals negative a. So this absolute value right here basically says there are two choices for your answer. And you can think about it. If you take the absolute value of -4, that is, oops, sorry. If you take the absolute value of x um, equals a, right? So what if I put um, let's see here. If I put the absolute value of 4 in here, I get 4. Or if I put the absolute value of -4 in here, I get 4. So either one of these would give me 4. So that's what this is telling you right here. It's telling you that when you substitute in a value for x, whether it's positive or negative, you can get the same answer. Okay, that is a possibility. So let's take a basic problem like this, 2x plus 6 equals 4. So here's how I want you guys to solve it when you're taking my tests and you have to show your work on exam day. This is what I expect to see. If you do it differently, I'm gonna not grade it the same. So please do it this way. So what I do is I do the positive version and I do the negative version as two separate problems. Okay, this is just there's other ways you can do stuff like this, but I really like doing it this way. So what I do is I do 2x plus 6 equals 4. So the positive version, you just pretend like you take off the absolute values and nothing changes. And then you solve it, you go -6 minus 6. Oops. 2x equals -2. Divide both sides by 2. Divide both sides by 2. So we have x equals -1. Okay, so that's the positive version. The negative version, you do everything the same, but now you put -4 over here, and now you solve. So, oops, -6 minus 6. So we have 2x equals -10, divided by 2, divided by 2. So we have x equals -5. Okay, so that means when we put either one of those in to the absolute value equation, we will get 4. So let's say that our solution set is x equals, and then sometimes they do it like this, oops, they'll write the little squiggly lines, -5 comma -1. They're not saying interval notation. This is saying x equals -1 and x equals -5. This is set notation saying these two are the answer. And I could check it. I could take and I could plug -1 in here and I could plug -5 in here. So let's do that over here on the side. Let's do 2 times the absolute value of 2 times -5 plus 6 better be 4. So this would be the absolute value of -10 plus 6. So this would be -4 equals 4. So then 4 equals 4, and that checks out. And then this one, we could plug in 2 times -1 plus 6 equals 4. So this would be absolute values, -2 plus 6 equals 4. So this would be 4 absolute value equals 4, which is 4 equals 4. That checks out. So you don't have to do this every time, but this is just what it's telling you. These are the two solutions. So this is how the computer may ask you for your solution set. On your work for exams, I'll accept this. But when you go to enter it in the computer, they're going to want it like this, I believe. It might just say, it might already have the x equals written. So just go ahead and give that a shot. All right, so now you guys pause the video and try this one without my help. Give this one a shot. Do it just like I did above. Do the positive version over here and do the negative version over here. Okay, now pause the video and give it a shot. Okay, so hopefully you guys are back. Let's do the positive version. The positive version, you just drop off the absolute values. And the negative version, you just change this side to -15. By the way, the reason that's actually happening is when you do the negative version, So let me show you. When you do the negative version, you're actually saying negative of whatever's inside of here, right? So then all I do is I divide both sides by -1 and cancel the negatives, okay? And that's why this side always turns to negative, right? So this will be -15. Now, if that side was already negative, that's, you know, that's something different. We'll talk about that in some of the other problems. So let's solve this guy. -1, -1, -1, -1. So this will be x over 5 equals 14. This one will be x over 5 equals -16. Now we get rid of a 5 in the denominator by multiplying by 5 over 1, by 5 over 1, 5 over 1 times 5 over 1. So we end up with x, so these cancel, become 1. These cancel and become 1. X equals, what is that, 70? And this one is x equals, take it as 80, -80. So these are my two answers, but once again, in the homework, I believe they're going to ask you to write it like this. Let me get out my notes real quick and just make sure I'm getting all of these correct. I'm not making any silly mistakes. Yep, so far so good, okay? All right, so let's take a look at another one. Now, the whole thing way back here is the positive version and the negative version, you must isolate the absolute values before you split the absolute value. Okay, so this is extremely important. Okay, so in this problem here, the absolute value was by itself. In this problem here, the absolute value is by itself on the left-hand side. Now you look over here, the absolute value is here, but there's also a -6. So we cannot do that before we want to do the positive version, the negative version, you must isolate. Okay, so I'm going to add 6. So this is my new problem, 2x equals 10. Now I can do positive version, negative version. Okay, so now we have 2x equals 10 and we have 2x equals -10. Divide both sides by 2, divide both sides by 2. So we end up with x equals 5 and x equals -5. And these would be my two solutions. Okay. Sometimes you have a situation where your absolute value equals 0. So in these cases, you do not have two answers. You will have 0 answers because if we do the positive version and the negative version, we have 7x equals 0 and we have 7x equals -0. But -0 doesn't make sense. It's just 0. So we end up with x equals 0 and x equals 0. So our solution is x equals 0. Okay, there is, I mean, I guess you could say it's a set with one element, but there's only one solution this time, not two. So just be careful of that. In general, they have two solutions, no solutions, or one solution. Let me think how you could get one solution. Maybe you can't. I'm sorry, this is the one solution, I'm sorry. So you have possibilities of no solutions, you have possibilities of one solution like this one, or you have a possibility of two solutions like these, like the ones above. Okay, so pause the video. Let's give this one a shot. Oh, as you can see, they already did this first step. I forgot to delete that part. Okay, so now we're going to be left with 3 times the absolute value of z equals -7. So I'm going to do the pause. I've got to divide both sides by 3. Okay, so now what I'm going to be left with is I'm going to be left with absolute value of z is equal to -7/3, right? So now if I do the positive version, the negative version, I'm already done. So here's the positive version, z equals -7/3. And here's the, I'm sorry, there's the positive version, here's the negative version, z equals 7/3. But there's something a little bit suspicious about this to me, okay? So sometimes with absolute values, you have to be a little careful in all math, you have to think about what you're solving for. So this problem I would call robot mode. So if you were in robot mode, you would say z equals -7/3, 7/3. And that would be your answer. And you'd feel pretty good. It's actually wrong. You cannot do that, because let's go back and look right here. Let's go back and look. Remember what this statement is saying right here. This statement is saying that an absolute value, which we know is always a positive number because it's the distance from 0, the absolute value of z is going to somehow give you a -7/3. Well, that's impossible. No absolute value can ever give you a -7/3. Now, again, that'd be different if there was a negative on the outside. That's a different problem. Just as written right here, this problem is impossible. So we say this cannot happen. So we say no solution. But I believe the better way to say it would be the solution set is the empty set. Oops. The set with nothing in it. Okay. Also, you could do this a 0 with a line. Oops, 0 with a line through it. This is also an acceptable way to write the empty set, or you could just write out the empty set. Okay. Any of these three will be counted as correct, but I believe the homework is going to want that one. Okay. But they'll give you like a multiple choice, where they'll say, write your answer or state that it's no solution, the empty set. Okay. All right, you guys, now we have something kind of weird. We have the absolute value equal to another absolute value. So technically, there's 4 scenarios that could happen. So remember how I told you that when you take off the absolute value, so this is 2x plus 4, oops. So if this is the positive version, 2x plus 4 equals, and then technically when you do this, you have the negative, oops, the positive version, nothing changes, right? That's the positive version. But that's only for, if I take off the absolute value here and were to leave it here, you guys understand it's kind of weird when you have an absolute value on both. So here's the thing. You could either have a positive and a positive. You could have a positive and a negative. You could have a negative and a positive, or you could have a negative and a negative. But here's the thing. If you do this one or this one, the overall will end up, when you divide both sides by a negative, right? When you divide both sides by a negative, you'll get a negative, okay? So this, if you divided, let's just say whatever's over here divided by -1, divided by -1, this will become negative, okay? Or this one, this is already negative, right? So you get negative on the left and a positive, negative on the right and a positive on the left. Now this one, when you divide by -1 and divide by -1, this becomes a positive and a positive. So we have this scenario matches this scenario, and then we have this becomes positive equals negative, but this is already positive negative. So this scenario will match this scenario. So there's still only 2 scenarios. So what I'm going to do is I'm going to do my positive version here, and I'll do my negative version here. And I'll show you how to do this real quick. So the positive version, you just do this one. Nothing changes. So then we solve. Let me add 1, add 1. Let me subtract 2x, subtract 2x. So this is gone and this is gone. This becomes 0 and this becomes 0. And we have 5 equals x. There's one of our solutions, okay? Then over here for the negative version, we're going to do 2x plus 4 equals negative, oops, negative. And then, so all I'm doing is this one now right here, guys. Negative 3x minus 1. But you have to distribute that minus sign. So this becomes 2x plus 4 equals negative 3x plus 1. All right. So now the thing is that we're going to subtract, oops, we're going to subtract 4, add 3, oops, plus 3x. This is gone, becomes 0. This is gone, becomes 0. So let's see what we have over here. We end up with 5x equals, what is that, negative 3. Divide both sides by 5. So this will be x equals negative 3 over 5. Okay, so now our solution set is -3/5, comma 5. And what we could do if we want is we could plug these in. We could plug 3/5 in. Let me see, let me double check and make sure this is -3. So you could plug this in to the original here and here, and then you could plug this into the original here and here, and you would get it to work. You can do that as practice if you guys would like. Let me see. I think that's enough for these. We can do one more. So pause the video, and now you guys kind of do it similar to how I do. You do the positive version, the negative version, but you put a negative in front of parentheses and distribute it. So pause the video and give this guy a shot. Okay, so hopefully you do your positive version here. Remember the positive version, nothing changes. And then let's do our negative version here. And remember the right side changes by 8 minus x. Okay, so let's add 2, add 2. So this will become x equal, oops, what am I doing? Sorry. Plus 2 plus x plus x. So this is going to become 0. This is going to become 0. Have to move the x's to one side. So this becomes 2x equals 10. So we end up with x equals 5. Okay, not so bad. Now let's look at this other one over here. So we have x equals, oops, x minus 2 equals -8 plus x. Okay, now let's solve. Let's do, oops, let me double check something real quick. Let's do plus 2 plus 2. And then let's do minus x minus x. So, oops, these cancel, become 0. These cancel, become 0. So the problem is this right here. This becomes 0 x's is equal to -6. Did I do this wrong? Let me see here. No, that's okay. So now does 0 equal -6? Well, the answer is no. So this is actually false. This cannot happen. This is a contradiction. So then that means our only solution is x equals 5. There is no solution for the negative version. It can't work. It can't be done. So whenever you get a false statement at the end, when all the x's disappear or the z's or the m's or whatever, you have to be careful. That either means there's infinite solutions or no solutions, right? So you got to double check those. So whenever you get this contradiction here, this is a contradiction. You just put a line through your equal sign. But that'll do it for this, guys. I'm going to switch over now to the next video. But thanks for watching. And I'm going to end the video now.